Welcome to this fourth and final recorded video for the 01 Jupyter Lecture Notebook. In this recorded video, I will also reference the supplementary file for this 01, for this first module on Markdown Tech Examples. So TEX is pronounced tech. And so this is how you do some mathematical typesetting. I just provide some examples here, but I also suggest that you look up a LaTeX Markdown cheat sheet on Google or Bing or whatever search engine that is your favorite to use. And you just look at what I'm doing by going in here and seeing how I made things larger in math, smaller, regular size, and the commands that I use. And just try making your own. This is probably going to take you a little bit of time. You're certainly not going to become a master at this. You're not expected to. I give you some links here as well to look at some things about what tech is, but I'm going to give you the basic idea of what to do. So the first thing that we're going to talk about are different formats for inline display math or larger display math and how I did these things. So I'm going to input that, go into here. It actually doesn't look like much when you look at it. The main thing to realize is when you use a single dollar sign around some mathematics, then that will display the mathematics in line. When you do $2 signs, then anything you put between the $2 signs is displayed as what is called display math. It will be on its own line. So let's just look at that real quick to see the difference. Euler's identity is e to the I pi plus 1 equals 0. Euler's identity is e to the I pi plus 1 equals 0. Now let's look at these again. $1 sign, $2 signs. All right? The difference, here it is in line. It's in line with the rest of the text. And here it is as its own display line. But the size isn't that much bigger when it's in a display mode. If you wanted it to be larger, here, notice the text size between this right here and here. It's much larger. The way I do that is I use a command like large. This is also shown in the these tech examples where I make fractions of different sizes here. And notice I use large with a capital L, huge, and huge with a capital H, and look at the difference in the size of the math. So there's ways for you to control things, and I did that also with there's some auto sizing things to do as well, and doing some display style, other things you can do. So that's just something to consider. There's lots of ways that you can format things. And then I just describe in a list, with a bullet list, what all the parts of the equation are. So E is Euler's number. It's the base of natural logarithms, the natural log that you probably remember. It's also the base for the typical exponential function, e to the x, that you're familiar with from algebra. I is the imaginary unit, which by definition satisfies the square root of I equals -1. And, that's wrong. Square root of -1 equals I. So I'll have that fixed in yours. So -1 is I. There we go. That's what we call I. So you'll get this document that I'm working with now, so you won't have that error. I had that error here. Pi is pronounced pi, P-I. Notice to make the symbol pi, I use a backslash and then pi. That's often what we do with Greek letters. So again, in the Markdown Tech examples here, if you look at the bottom, I talk about lowercase Greek letters. They're what you typically do. You just do backslash and then alpha, backslash beta, backslash gamma, backslash delta, backslash upsilon, nu, omega, tau. You could do pi, any of those typical Greek letters, and they will appear as you want them. So backslash is the command to do a lot of things in LaTeX. For instance, to make fractions, there's this backslash frac, F-R-A-C, and then I use curly brackets to make the numerator, and then I put curly brackets around the denominator, and you notice I have that everywhere. And so these use curly brackets to make groups of things in the math text, and backslash is put before commands like making a fraction, or let's see what other commands there are. Auto sizing parentheses. If I want to make a right paren or a left paren with some auto sizing, I'll use backslash left, backslash right. And that backslash is a special command in the tech world, and it's letting you know this is going to be some sort of like interpretive function within the tech commands. So, all right. There's not a whole lot you need to know. I'm just giving you some initial things to look at and options to format. And so you're going to have to go through these Markdown tech examples and just kind of look at them carefully. Again, edit, add your own, make sure you're comfortable with doing some of this. And I show you some, common things that are useful from calculus, arrows and dots. This is another one. Notice I want a right arrow, backslash, right arrow, right? It's pretty sensible. You want a right arrow, you want a left arrow, backslash, left arrow. But if I want, look what happens if I make it capital right arrow instead of lowercase right arrow. Look at the difference. There's that arrow, and now it looks more like the arrow you use when you do an implies. This is a long right arrow. What do you think you do there? Backslash long right arrow. It's not that difficult to imagine what a lot of the commands are. And if I do a capital L for capital long right arrow, it looks like a longer version right there of that one. And if I wanted two arrows, I'd make a right arrows, right? So I'm just giving you ideas of, some of the actual logical sense of the way these commands are defined in tech. So once you get the hang of it, you can kind of almost guess at what these things should be, even if you've never used them before. And you go, boy, I'd like a symbol that was like an upward right arrow. How would I do that? Well, it uses like compass directions. So this is a northeast arrow. Then there's a southeast arrow, a northwest arrow, and a southwest arrow. If you think of a typical compass that's northeast, southwest, or northwest, southeast, however you want to write it, you just use arrow like compass commands to direct the arrows. So same thing. There's things like diagonal dots, D dots, vertical dots, V dots, horizontal dots, a C dot or C dots. C dot is 1, C dots is 3. So these are just things that you start to pick up as you get more into typesetting mathematics and making your documents look more beautiful with typeset math inside of them. And then I ask you to tech yourself, do some teching. I'll go through part of this with you, but I'll leave some of it for you to do. And I know this will probably take you a little while to do. It might take 30, 40 minutes to do this one activity, and it might get a little frustrating. I'm here to help. Ask questions on the discussion board if you're having any difficulty with it. Let's look at Stirling's approximation, the more precise formula according to Wikipedia. And I'm just going to do one of the format options. So I'll do the inline math, and I'm not going to do the bullet list, but you should. You should always say what everything is in your equation. So with that, here's I'm clicking on the wrong thing. Here's Stirling's approximation. Here's the more precise formula. This is on Wikipedia. And you see it's in factorial. And you see this symbol here, right? It asymptotically approaches something that looks like the square root of 2 pi n, right? So this is the two quantities are asymptotic. That sign, that symbol, that tilde. The square root of 2 pi n times the fraction of n over e raised to the n power. So if I was to come here and try to type that in here, so where your answer goes, the first one, and I want to do this in format, right? It was in factorial sim. I'm just going to show you that real quick. I'll just do Control Enter. Sim is what gives you the tilde. If you're trying to figure out how to get that tilde, it's sim, \sim. And then I need the square root of 2 pi n. So square root, guess what that's going to be? \sqrt. And if I want a bunch of things, if I want to group things to be under the square root 2 pi n, then I need to put curly brackets around there to say this is what's going to go under the square root, because that's what groups things together, and I'll have 2 pi n. And I need to do a space there because if I do that, watch, it just puts it in parentheses. It's like, what do you mean pi n? It needs to render the pi and then get the n separate. So you need a space right here for that to work properly. And then I need times this fraction of n over e that's in parentheses. I want it auto-sized. That would be like if I looked over here and I wanted larger parentheses around a fraction, and I said, how did that work? I used the left and right commands before the parentheses. So here, I'll have left and right. I'll just go ahead and get those in so that everything's going to work. And I'm going to put for my fraction, my numerator and denominator. And what's the numerator again? It's n. What's the denominator? It's e. And this whole fraction was raised to the n power, if I recall correctly. Yeah, it's raised to the n power. So there's my n line. There it is. So you're supposed to use two format options. I would say this is format 1. This is the inline option. So inline option, right? Because it's in line with the text. But you should add a bullet list. You know, what is n? What is pi? And it's probably better to put all these in dollar signs so that they look correctly. They look correct, excuse me. So I'm just asking the question. You need to say what they are, just like what I said here, like where these things are. And you should say what they are in some option, right? So like where, something like this, where, and then you have your list and you'll say what these things are, just like I said things up here. And you'll just look at this and understand. Pi is the usual pi, e is the Euler's number, and what is n. So you just need to say what each of these things is. So that's it. That you do it in a different, you could do format 2 or format 3 for the other format. You got to do at least 2 of the above format options. Create your bullet list, make sure you have it within each one, just so that you're doing what I'm asking. And then here, part B is I ask you to look on this Wikipedia page for the logistic function, and I actually provide the link directly to population growth. This is just more practice. So it should take you right here. This is, I guess Wikipedia wants me to donate right now. This is the differential equation that describes population growth, so you need to write that out. And then this is the solution to the equation, and you can read it right here. This is the solution to the equation. So you'll need to write this out as well. Just write one, or you don't need to write the, P of t equals both of these. Just pick one. Pick one or the other. I would go with this first one, quite honestly, rather than have a fraction within a fraction. I think this will just be easier to tech correctly. So you need to do that, and then you need to explain what each of these terms are. The k, the p naught, the r, and of course what the e is here. And here you'd have to say what dp dt is, which is the derivative of the population with respect to time. So I just ask you to do that here just so you get some practice with mathematical typesetting. And again, if you have any trouble with that, just ask on the discussion boards, ask some classmates. We're here to help, and I'll be talking to you in Module 2 otherwise. So thanks for listening.